Okay, guys, I got a few questions over the review assignment, which is great. I love to see your questions about needing some help on some of these. That gives me a good idea about what you need more help in as we go forward. So I'm going to post the answers here, but I thought I'd give you some quick tips and tricks. Remember to help you out, label these sides according to the angle that you're trying to find, right? Looking for angle B. The opposite side is over here. The adjacent is opposite the right angle, and so the other one is the adjacent. What did I say? Sorry. The opposite is over here, right? The opposite of the right angle is the hypotenuse, and the one next to B, but not the hypotenuse, is the adjacent. So we have the adjacent hypotenuse. We would use cosine and then use inverse cosine to actually find the angle, okay? So the answer there, the best answer is B. At some point you'd have to use inverse cosine, but you would start with the cosine. Okay, number 2, nobody asked for that one, but there's again my, you can see how I'm doing this, labeling my side, so I know I got to use tangent because it's opposite and adjacent are involved in the angle. Make sure you're not using this angle. If you called this angle 52, you're not going to come up with the right answer, right? You're going to be using the complement of 52, which is not the correct angle here. So this angle is 52, so you can make this angle 52, alternate interior angles. Okay, number 3 was the first question I saw that people asked for on the review. I don't know why this thing's not moving. There we go. Okay, so to recap the altitude leg rule and the altitude rule, we have to have. This situation only works when you have two of these going on. You got a big right triangle, and within that right triangle, you've got an altitude drawn to its hypotenuse. Whenever we have that special situation, remember, all 3 of these triangles are now similar. The 2 small triangles and the big triangle are all similar to each other. But we came up with some special formulas, right? We came up with some special ratios. The altitude is the geometric mean between the 2 pieces of the hypotenuse, the 2 projections of the legs onto the hypotenuse. Okay, so x is projecting 6 onto the hypotenuse, and this side is projecting 24 onto the hypotenuse. The whole hypotenuse, however, is 30. Okay, so we're going to need that to eventually use x in a formula, because x is the geometric mean between 6 and the whole hypotenuse. Its projection is 6, and its whole hypotenuse is 30. So x squared is going to be 6 times 30. Okay, y squared is going to be 6 times 24. Okay, let's move on over here. Y squared is 6 times 24. A couple helpful hints and tricks and hits and tricks, right? Y squared is 6 times 24. You may not need to multiply that, because you can say you're going to take the square root. And we take the square root, you know 24 is 6 times 4, so that's great, right? That takes a 6 out, and the square root of 4 is 2, so it's 6 times 2 is 12. Notice I got the square root pretty easily without doing all that multiplying. And the leg rule, we're taking 6 times 24 plus 6, which is 6 times 30. Again, we're going to take the square root of both sides, because x squared is 6 times 30, right? So I know I got to do that. No need to multiply yet, because I know 30 is 6 times 5. So I'm taking the square root of 6 times 6 times 5. You take a 6 out, 5's left inside. So you got 6 root 5. Okay? That's how I do it. I don't know if anybody asked about number 4, but it's worth talking about. I mentioned this in one of the classes, that this is actually a 3, 4, 5 right triangle, because these 2 sides are on the ratio of 3 to 4. So this side has to be 5x. So you could, an easier way to do this problem would be to say this is a 3, 4, 5 right triangle because of the ratio here. This side has to be 5 in the same ratio of 5x. So 5x equals 20, x equals 4. That's a hell of a lot easier, right, than finding x equals 4 using Pythagorean theorem. Once you find 4, you need to add all the sides together to get the perimeter. We add all together and we get 48. Okay, the 4 is being multiplied by the 4 here and the 3 here, or multiplied by 7, because 4 plus 3 is 7. Okay, nobody asked about 5, a little surprising, but remember you got the sun shining down. There's an object here. You're going to need this for the project you guys are doing. You got an object here. It's the flagpole. The flagpole, because of the sun shining down on it, the flagpole in this one little area of the ground makes a line that looks like the pole is laying down on the ground, but it's projected onto the ground by the sun with its shadow. So the projection of this onto the ground is 18.2. That's its shadow. If you notice, the rays coming like this. So this is the angle of elevation. And you've got the opposite and adjacent side involved here. So to find the angle, you're just going to use tangent. Okay. Okay, somebody asked about number 6. I'm going to start a new video there.